So here we have example 6, where it's the expected value intro example. So you play a game where the roll of one fair die determines whether you win or lose. If you roll a 5 or a 6, you win $5. If you roll a 3 or 4, you win $0, which is called break even. If you roll a 1 or 2, you lose $2. So how much do you win or lose on average if you play a really long time? So here with this equation, we can write this as mu of x is equal to the expected value of x, which you can write as the summation of x times f of x. So we can use this formula. So now, when we go over if you roll a 5 or a 6, you win $5. So if the probability of winning 5 is equal to the probability of rolling a 5 or a 6, which is 1/3, because it's 2 6 and it gets reduced to 1/3. Now the probability of breaking even, which is the probability of getting a 3 or a 4, that's also 2 out of 6, so that's 1/3. Now the probability that you lose $2 if you get a 1 or 2, that is the probability of 1 or 2, which is also 2/6, which is also 1/3. So now we can solve this equation, what we have right here. So the expected value of x is equal to 5 times 1/3 plus 0 times 1/3 plus -2, because you're losing $2, -2 times 1/3. And if you do the algebra, this should all equal to exactly $1. Now we can move on to example 7, which is a circus farmer observe the following distribution of x, the number of oranges per tree. So here we have the table, and A is asking what is the expected value of x, and B is asking what is the variance of x. We can first start with A, where we have mu of x is equal to the expected value of x, which this is also equal to the summation of x times f of x. So now we can write this as our x value is 25 times f of x, which is 25 times 0.1 plus 30 times 0.4 plus 35 times 0.3 and plus 40 times 0.2. So now we can plug this into a calculator, which gives us 33. Now B, what is the variance of x? Now we know the variance of x is equal to expected value of x minus the expected value of x squared. Now we know one of them, but we have to find the expected value of x squared. So we'll find that right here. Very simple, same formula, but instead of x times f of x, it will be the summation of x and x squared times f of x. So we have 25 squared times 0.1 plus 30 squared times 0.4 plus 35 squared plus times 0.3 plus 40 squared times 0.2. 35, okay, plus 40 up square. Now this would give us 1,110, so the variance of x would be 1,110 minus 33 squared. Now if we do the calculations correctly, it should be right there, 21. So now we can move on to example 8, which is what is the expected value of g of x is equal to 2x plus 1, and B is asking what is the variance of g of x is equal to 2x plus 1. So let's get started with part A. This is also a continuation of example 7. So we could use the same data as 7. So we have the expected value of 2x plus 1, which is equal to the summation of 2x plus 1 times f of x. So now using the data from before, the chart from before, we can do 2 times 25 plus 1 times 0.1 plus 2 times 30 plus 1 times the f of x, which is 0.4, plus dot dot dot, which would equal 67 if we add them all up. Now B is asking for the variance. So the variance of 2x plus 1 would be the summation of 2x plus 1 minus mu of 2x plus 1 to 67, which we had in part A, all squared times f of x. So we continue on. We have the summation of x times 2x minus 66, because 67 minus 1 is 66 squared times f of x. Yep. Now if we do the math, we have 2 times 25 minus 66 squared times 0.1 dot 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 plus 2 times 40 minus 66 squared would, and then times f of x, which is 0.2, which would give us 84. So now we can move on to example 9, which is part A is asking what is the expected value of g of x is equal to 2 of x plus 1. B is asking what is the variance of g of x is, and C is asking for the standard deviation. So now we can start with part A, which is the expected value of x, which is 2x plus 1, which is equal to the expected value of 2x plus e of expected value of 1. We can factor out the 2, so we get 2 times the expected value of x plus 1, which would then, we can rewrite this as 2 times 33 plus 1, which is equal to 67. Same thing that we got from the last problem, just another way of solving it. Part B is asking for the variance, which is the same thing as part B on the last problem. So we get the variance of 2x plus 1, which is equal to 2 squared times the variance of x, which is equal to 4 variance of x, and then 4 times the variance of x, which is 21, which is 84. Now we can move on to C, which is the standard deviation. Now, how do we find the standard deviation? Pretty simple. Standard deviation of 2x plus 1 is equal to the square root of the variance of 2x plus 1. And the variance of 2x plus 1 is the square root of 84. Yep. Now we can move on to example 7. First part is saying, what is the probability of x equals 2? Now we can see that x equals 2 would be 0 because we can't see any x values of 2. Now in the part B is asking, what is the probability of x less than 2? Probability, that would be the probability of x equals 0 plus the probability of x equals 1, which is equal to 1/3 plus 1/2, which is equal to 5/6. C is asking for what is the expected value of x. Simple. We have to do the summation of x times f of x, which is equal to 0 times 1/3 plus 1 times 1/2 plus 3 times 1/6, which is equal to 1/2 plus 1/2, which is simply just 1. D is asking for the variance. Now we know the variance is equal to the expected value of x squared minus the expected value squared. We know the expected value is, but we don't know the expected value of x squared, so we have to find that out. Which is fairly simple. It would be the summation of x, summation x squared times f of x, which is equal to 0 squared times 1/3 plus 1 squared times 1/2 plus 3 squared times 1/6, which is equal to 1/2 plus 9/6. If we add them up, it would give us 4/2, which is equal to 2. Now we can just plug that in. So the variance of x is equal to 2 minus 1, which is, yes, expected value of x squared, same formula. So it's just 2 minus 1. Now part E is asking for the expected value of y, where y is equal to x minus 1 squared. So we can write this as the expected value of x minus 1 squared, which is equal to the expected value of x squared minus 2x plus 1. And we can write this as the expected value of x squared minus 2 times the expected value of x plus 1. Now we would get 2 minus 2 times 1 plus 1, which would just be 1.